बायोमिक्स अब आज के इस वीडियो में हम डिस्कस करने वाले हैं रेगुलेशन ऑफ फेरिटिन ट्रांसलेशन बाय आयरन। ये जो फेरिटिन जो प्रेजेंट है इसका जो रेगुलेशन है इट इज बीइंग रेगुलेटेड बाय आयरन। सो फर्स्ट ऑफ ऑल वी हैव टू अंडरस्टैंड व्हाट इज दिस फेरिटिन। दिस फेरिटिन इज ए आयरन स्टोरेज प्रोटीन। जब कभी भी आयरन का कंसंट्रेशन सेल में ज्यादा होगा देन दिस आयरन नीड्स टू बी स्टोर्ड. So it requires ferritin protein. During this time, the ferritin protein is being translated. But when the concentration of iron is low inside the cell, it does not require for the storage. So during this time, the ferritin protein is not translated. In this way, this iron regulates the translation of ferritin. In the mRNA, it is having a 5' region and a 3' region. And it is having a iron regulatory element which is forming a loop-like structure. When that is a loop-like structure, it cannot form the protein, because for this synthesis of the protein, it requires ribosome and other machineries to come and bind. If that is a loop-like structure, the ribosome and other machineries cannot come and bind in this region. So let us first understand how this iron is regulating the formation of ferritin. When the concentration of iron is low inside the cell, here we are having a 5' region and 3' region of mRNA, and here there is a IRE site which is forming a loop-like structure. In the IRE site, a protein comes and binds which is known as IRP or iron regulatory protein. It will not allow for other initiation factors like initiation factors 4A, initiation factors 4A, 4B to come and linearize this structure. So, upon binding of this IRP with IRE, the small ribosomal subunit cannot bind in this region, and there will be no transformation of this ferritin mRNA. Due to which there will be small ferritin, as there is low amount of iron inside the cell, there is no requirement of ferritin. So, ferritin is not synthesized. Now, let us see the second statement, that when the concentration of iron is more inside the cell, during that time, this iron, what does it? It comes and binds with this IRP protein. Now, this IRP protein cannot bind in this IRE region, due to which now the elongation initiation factor EIF 4A and 4B can do their work by linearizing this mRNA, by disrupting the loop, and after that the ribosomal subunit can bind in this region along with some of the initiation factors of translation. They can bind in this region and they can form the large ferritin pool, due to which a high amount of iron which is present inside the cell, it can be stored. So let us see how the initiation factors come and bind. When there is no concentration of iron, when there is low concentration or no concentration of iron, during this time, this IRE, there is formation of IRE. In this IRE, the IRP protein can bind, and it will prevent the EIF4 FB to function, 4A and B to function. What was the work of this EIF4A and 4B? They were helping in disrupting this loop. They were making this mRNA in a linear form, due to this the ribosomal subunit as well as the initiation factors can come and bind and form the mRNA. See, in this concentration, when the iron is more, during this time the iron binds with the IRP protein, due to which it cannot bind with the IRE. And now the EIF4A and 4B does their work by linearizing this mRNA, and the ribosomal subunit come and bind in this region along with some initiation factors which will help in the formation of this ferritin protein. Here the ferritin protein is being formed, due to which the iron will be stored. It is the storage form of iron. It is a protein which stores the iron. From this topic, there are certain questions which has been asked in CSIR net. Let us solve this question. The 5' UTR of ferritin mRNA forms a stem loop structure called the iron regulatory element, which is known as IRE. The iron regulatory binding protein binds the IRE. Yes, we have already discussed that in the IRE element, IRBP comes and binds. The following statement permit reference to IRBP-IRE interaction. The first statement is IRBP-IRE interaction prevents EIF4A from resolving the stem loop structure, thus preventing initiation of translation of ferritin relief. Yes, this is the correct statements. When the IRE and IRB binds, it does not allow the EIF4A to come and do their work, and it does not allow in resolving the stem-like structure. So if there is no resolution of the stem-like structure, there will be no formation of ferritin. Now let us see the second statement. IRBP-IRE interaction recruits EIF4A. This is the contradictory statements with A. It does not recruit it. It does not allow the work of EIF4A to be done. So B is the incorrect option. So A, we can eliminate A, we can eliminate B. Okay. Now C. In presence of ferrous iron, IRBP is unable to bind the IRE. Yes, it is the correct statements. When there is presence of iron, IRBP is unable to bind with IRE. Now D. EIF4A binds directly at the 5' UTR and disrupts the stem loop structure, thus promoting translation initiation. No, it does not disrupt the stem loop structure. It helps in unionizing the structure. So A and C is the correct option. Okay.